All right, let's get right into it. Today, we are running the C# and .NET interview gauntlet. We're going to cover the core concepts you absolutely need to know to nail your next technical interview.
So, imagine this. The clock is ticking and the pressure is on. You've got just 5 minutes to prove you've mastered C# and .NET. You think you're up for the challenge? Well, let's find out. Okay, first things first, every single great interview starts with the fundamentals. If you get these right, you're building a solid foundation for everything else that's going to come up. So, first up, value versus reference types. Honestly, the easiest way to think about this is a photocopy versus a shared link. A value type, like an int or a struct, is its own little photocopy. If you change the copy, the original is completely untouched. But a reference type, like a class object, that's just a link, a pointer to one single piece of data sitting on the heap. So if you change it through one link, you are changing the one and only original object for everyone. Okay, so let's put that concept to the test with a classic interview question. Take a good look at the code on your screen. Can you predict what it's going to print out? So here's what's happening. We start with an integer I, and we set it to 5. Then we assign it to an object b, and that move right there is called boxing. Next, we increment the original I. Then we unbox b back into a new integer c and increment that. So finally, we print I and b. Got your answer?
The output is 6 and 5. And here is the crucial point you have to remember. Boxing, assigning a value type to an object, creates a brand new copy on the heap. So when we incremented I to 6, it had absolutely no effect on that separate boxed value of 5 that was stored in B.
All right, now that we've got that foundation locked down, let's build on it and move to object-oriented principles. This is the real heart of C#. This is where you prove you can architect clean, maintainable code. Ah, here it is. This is one of the most classic interview questions of all time. It seems simple, but getting the distinction crystal clear, that shows you have a really deep understanding of polymorphism.
And here's the breakdown. It's pretty simple when you see it laid out. Overriding with all about changing an inherited method's behavior. You have the same name, same parameters, but a new implementation. Overloading, on the other hand, is about creating multiple versions of a method inside the same class, each one with a different set of parameters. And why can't you just create an instance of an abstract class? Well, because it's designed to be a contract, an incomplete blueprint. It might have methods that are just declared with no actual implementation. It's up to the classes that inherit from it, the concrete classes, to fill in all the blanks. Trying to create one directly is like trying to build a house from an unfinished plan. Just can't be done.
All right, let's get into the nitty-gritty, the keywords. You can think of them as the rules of the road for your code. They control access, behavior, and, really importantly, safety.
Now, this is a fantastic question that gets right to the core of multi-threading. When an interviewer asks this, they're not just checking if you know the syntax. No, they're testing your understanding of thread safety and memory management. And this really illustrates the point perfectly. The lock statement needs a single, shared object to act as the key for a critical section of code. Only one thread can hold that key at a time. A value type would be a copy, right? So each thread would get its own key, which completely defeats the purpose. A reference type provides that single, shared object that everyone needs to reference. So what about new versus override? The whole difference comes down to one word: polymorphism. See, override continues the polymorphic chain, so the method of the actual object's type gets called. But the new keyword, it breaks that chain. It just hides the base class method. With new, the method that gets called depends entirely on the variable's type, not the object it's pointing to. Okay, let's shift gears and get into the features that really define modern C#. These are the tools that make your code more concise, more expressive, and frankly, just a joy to write.
Lambda expressions? Yeah, I know they might look a little strange at first, but they are incredibly powerful. Just think of them as a shorthand, a quick way to create a function right where you need it without all the ceremony of a full method definition.
And these Lambda expressions are the engine that powers one of C#'s most beloved features, LINQ, which stands for Language Integrated Query. It basically lets you write these SQL-like queries directly in your C# code to filter, sort, and transform collections of objects. It is just an incredibly expressive and readable way to work with data.
Okay, for our final section, we are popping the hood and looking at the .NET runtime itself. Understanding this stuff, that shows you're not just a coder, you're an engineer who really understands the platform you're building on.
The .NET garbage collector is just a marvel of engineering. It works on one key observation: most objects die young. So all new objects go into what's called Generation Zero, the nursery. If they happen to survive a cleanup, they get promoted. And this whole system is incredibly efficient because the collector focuses almost all its attention on Gen Zero. Knowing this actually helps you write better code.
And what about reflection? This is a powerful, almost magical concept. Reflection is like giving your program a mirror. It lets your code look at itself while it's running. It can inspect its own types, its methods, and its properties, and even create objects and call methods dynamically. Okay, for our final question, let's talk about a truly elegant C# feature. Imagine you want to add a new helper method to the built-in string class. I mean, you can't just go and change the source code, so are you out of luck?
The answer is a resounding yes, and it's all thanks to extension methods. This brilliant feature lets you write a special kind of static method that can be called as if it were an instance method on the original class. It's like a secret weapon for cleanly extending the .NET framework itself.
And there you have it. You've run the gauntlet, from the foundational building blocks all the way to the deep magic of the .NET runtime. You've proven you have the knowledge. So the only question left is, what incredible things are you going to go build with it?